In this video, I will talk about using JAX-RS to create RESTful web services. One of the surprising things about the internet is that simplicity tends to be very successful. HTTP is simple enough that a basic web server can be written from scratch in just a few lines of code. The most popular application layer protocols that have been built on top of TCP/IP are text-based or have a simple binary structure. I think a reason for this is that the simpler the protocol, the easier and cheaper it is to implement. The easier it is to implement it, the more programmers that will implement it. Metcalfe's law states that the value of a network is proportional to the square of the number of connected users. So, the more programmers that implement it, the more users the protocol will have, and therefore the more valuable the system becomes. A perfect protocol might seem more valuable initially, but these network effects mean that a simple, cheap and pragmatic protocol often turns out to be more popular and valuable in the long run. This brings me to SOAP. SOAP has become easy to use thanks to a huge amount of engineering effort by tool developers and IDE developers. As a result, SOAP is great for service-oriented architectures within organizations. However, the underlying technology is not so easy. REST is much easier, and I believe that this is why REST has become very popular and has eclipsed SOAP for most public-facing web services. So what is REST? Well, there's no single answer to that. There isn't a formal specification like SOAP. It's an architectural style that's become popular but isn't always implemented consistently. Rather than being based around methods or objects, it's based around resources identified by URIs. So this is a bit like giving each kind of data in your system a separate web page. These resources can have multiple representations, so JSON or XML for example. Then to query, change or create those resources, just use the standard HTTP methods like GET or POST. Suppose you have a chat server as part of a social network. With SOAP, you might call methods such as add message and get message. In REST, you might create a message by a HTTP post of data to one URI, and you could retrieve messages by a HTTP GET method on another URI. You could argue that it's all equivalent, it's just a different format for the same information. It's just sending a request and getting a response back over a network connection. However, this architectural approach brings us many benefits. It's simple, it's easy to understand, and since everything is HTTP, you can even use your web browser as a client. Because it's normal HTTP, there's no state, and it can be cached easily by proxies, so you get scalability benefits. And it's already the language of the web, so it's very portable, uniform, predictable, and highly compatible. One downside is that because it doesn't have any interfaces or formal standards, you need to read the documentation of each web service to understand exactly how to call it. Okay, so instead of methods of SOAP or RPC, you use HTTP methods to access URIs. But then what about the format of the data? Well, this depends on the particular application. The data could be represented in XML, JSON, or some other format. What this means is that when you do a HTTP GET request on a resource, for example, you might get all the messages, you could receive an XML document like this. Alternatively, you could receive JSON. JSON stands for JavaScript Object Notation. It's just a simple syntax for representing data in a way that is compatible with JavaScript. You could copy and paste this data into JavaScript and it will create an object for you directly. If you're using a web service, the decision about whether you'll receive XML or JSON or something else should be specified in the documentation that the web service provider has published. Some web services support both simultaneously, and you can explicitly request a type using the URI or either standard HTTP accept header. A service that follows the REST architectural principles is often described as being RESTful. And there are lots of RESTful APIs out there. Here's the documentation for one. It's offered by a company called Twilio. You can use the web service to communicate with phone networks. For example, you can make and receive phone calls. You can see here that to make a phone call, the documentation tells us to perform a a HTTP post request to this URI. The parameters are encoded using the same form URL encoding that the browser uses when posting data to a HTML form. In Java EE, JAX-RS makes it very easy to use these web services and also create your own web services. Let's start looking at how you create your own web service. First of all, you need to have a concrete subclass of application in your project. Annotate it with application path to tell JAX-RS the base URL for all of your web resources. So in this case, all of our RESTful web services will start with API. So this class is a simple configuration file that can go anywhere in your project. Once you've got the configuration, then it's very easy to create your web service. Here's an example. First, you'll notice the use of path. At the top, you can see that the path to this resource contains message. Now remember that the application path is API, so this class will handle resources at API/message. This class has several methods inside. The methods with get and post annotations are used to handle get and post requests to API/message. The methods with get and post annotations, as well as a path, are used to handle subpaths. So for example, the getMessages method is used to handle a path such as API/message/since/45. The code might return a list of messages since the ID number 45. You'll notice that this method has a bit in curly brackets. This is a wildcard. It matches any value in the URI and then stores it in a parameter named ID. This value is then automatically bound to the last seen parameter of the method. The name ID in the path param annotation is the same as the bit in the curly brackets of the path annotation. So path param basically says, take that bit at the end of the URL matching the wildcard and make that a parameter to the function. In add message, there's a different kind of param annotation. This one tells JAX-RS to get the value in the posted form data named last seen and pass that as a parameter to the method. When your web server receives an incoming request, it will search for the best matching resource method. So this is why there are two methods for the resource API/message. It will choose between these two methods based on whether the request is a GET request or a POST request. You'll notice that these methods are returning ordinary Java objects. In a minute, I'll explain how those objects get converted to XML or JSON. But first, there are other annotations in the JAX-RS specifications. I don't want to bore you with the details, but I'd like to give you a taste of what's possible. For example, you could have methods that handle different kinds of supplied content types. And you could also have methods that produce different kinds of content types. The application server will choose the right method that matches the supplied content types and the preferred response type in the HTTP accept header. You can automatically bind parameters from different sources. I've already shown how you can bind parameters supplied in a URL using path param, but you can also bind parameters in the query part of a GET request URL, of the HTML form parameters, and even values stored in cookies. Then finally, you can return different kinds of objects. If you return a string, JAX-RS will just return that value directly. If you return an object, then JAX-RS will automatically convert it into XML or JSON. You can also use a response class to build a more complex response, involving redirects, errors, special response codes, and custom headers. Now, you may be curious about how JAX-RS automatically converts objects into XML or JSON. This is part of a related specification called JAX-B, the Java Architecture for XML Binding. The simple answer is that all you need to do is ensure that your class is serializable and annotate it with XML root element. This tells JAX-B that it's okay to automatically turn instance of your classes into XML. The default configuration does a pretty good job. It will turn each property of your class into a separate XML element. So, by default, your XML will look something like this. JAX-B has a range of other bindings that allow you to more carefully control what the XML looks like. You can find all of them by looking at the JAX-B documentation. Suppose that instead of having each part of the message in a separate element, we wanted to use attributes and store the message text directly in the value of the element. Then you could use annotations such as these. I've marked the ID and timestamp to become attributes, and the message should be used as a value directly. If you use JAX-B with these annotations, then you'll end up with something like this. Fortunately, you don't have to do the same thing again with JSON. When JAX-RS converts an object into JSON, it makes use of the same JAX-B bindings. So this means that all you need to do is annotate your class with XML element. You can also use the JAX-B annotations to override the defaults. So here, I'm using a custom name in the JSON or the XML, and I want the word timestamp with a dash. When JAX-RS converts it to JSON, it would produce output that looks like this. So that's how to create a web service. But once you've created a RESTful web service, how do you use it? Well, the first thing you need is those class files with JAX-B annotations. This is so that when you receive a response, the XML or the JSON can be converted back into Java objects. So once you've got those JAX-B mappings set up, you can use the JAX-RS client. The JAX-RS client is designed to make it easy for you to use RESTful web services. To use the client, you follow these 5 simple steps. First, you create an instance of the JAX-RS client. Then you set the URI of the resource. Then you create a request. Then invoke the request. Then when you're done, you close the client. The JAX-RS client uses what is sometimes referred to as a fluent API. Instead of doing those steps one after the other, you can chain them all in a single line. Here's what it looks like in Java. I create the JAX-RS client, I set the URI of the resource, I create the request, then I invoke the request, and then when I'm done, I can close the client. It's that simple. Suppose you want to pass some parameters. In this code, I'm posting an XML document. JAX-B will automatically convert the object into JSON. The requested result type is also JSON, and the client will use the JAX-B bindings to decode that result back into Java objects. You can use path parameters inside the JAX-RS client. In this example, I've set up a generic path with a wildcard for the ID, but then resolve that ID to refer to a specific value. In this example, I'm encoding some form parameters. These parameters are sent to the server using the standard HTML form URL encoding. In the post request, I've specified that the result should be a list of messages. This is unfortunately a little bit complex, but you can just remember it as a trick that needs to be used when you tell the JAX-RS client to return a list of objects rather than just one object. Behind the scenes, this is necessary because Java code doesn't have access to generic information at runtime. At runtime, there's no difference between a list of messages and a list of objects. This is a clever trick that tells the JAX-RS client that yes, you really do want a list of message, not just a list of objects. I've covered a lot of the JAX-RS client and server code, and I hope it's given you a taste of what's possible and an understanding for some of the reasons behind JAX-RS. I believe that creating and using RESTful web services is the kind of thing that is best learned through practice. There's no point in me explaining every single option and every single possibility, because you'll never memorize every case. I know I keep forgetting them myself. But if you know what is possible, then you'll be able to write your web services with the documentation or examples at your side. The server-side resource classes and the client-side request code always follows the same formula. Almost anything you can imagine is possible. You just need to plug in the right combination of method calls or annotations to get the output you want. As a final point, if you're curious about the lifecycle of the server-side resource class, then you'll be pleased to know it's very simple. The JAX-RS specification doesn't define a complex lifecycle. It just states that by default, a new instance is created for every single request. But this can be overridden by other technologies. A benefit of the simplicity is that on Java EE, you can make JAX-RS use any lifecycle you want. You can use the EJB lifecycle if you want all the features of EJB like transactions and concurrency control. Alternatively, you can use the CDI dependency injection annotations if you don't need the EJB features, or if you want to keep track of user state through cookies. All you need to do is annotate it with an EJB annotation or a CDI annotation. So your JAX-RS service could be, for example, a singleton EJB, a stateless EJB, a session scope CDI bean, an application scope CDI bean, or even just a request scope CDI bean. Just put the annotation on your class and it will work with EJB or CDI. If you don't have any other annotations, then it will just create an instance per request.